We gave a general introduction to chemical process instrumentation in lecture 1. We talked about motivation, we talked about why should you measure, we listed the names of the different chemical process variables that we will be interested in, and measuring instruments for measuring those variables will be covered in this lecture. So, let us start with lecture 2. So, today's topic will be types of measurement applications. Here essentially we will be trying to figure out, can we classify all the measurement applications into a limited number of categories. So, people measure with various purposes. So, is it possible to classify those requirements? So, what are the different types of measurement applications? We will try to see in the first in today's lecture. Next, we will talk about direct measurement versus indirect measurement, and we will be talking about various functions of an instrument. The primary job of an instrument is to measure a process variable, but while doing so, it serves several functions. So, we will try to list those different functions for an instrument. Now, let us start with types of measurement applications. The first measurement applications is monitoring or supervision of processes and operations. Please note this term, monitoring or supervision of processes. As the name suggests, you only monitor the process, you do not control the process. A process is going on, several measuring instruments are placed in the process. So, they are either indicating or they are giving you signals about the measured quantities. You are monitoring those process variables. Suppose you are monitoring what is the temperature in the top of the distillation column, what is the liquid level in the reboiler in the distillation column. So, these informations can be monitored at the site of measurement, or it can also be monitored sitting in the control room. So, there can be various types of instruments which can locally indicate the values of these measured variables at the site of the measurement, or there can be instruments which will be sending out the signals about the measured medium to the control room, and sitting at the control room you will know what is the temperature, what is the pressure, what is the flow rate in different process units in your industry. So, monitoring means keeping eye on those process variables. So, essentially it keeps track of some quantity. No control action is taken ordinarily, because that is another different kind of application. Monitoring by itself is a class of application, and homely example will be, say, your water meter or gas meter or electric meter. So, these meters keep track of the commodity that you have used. So, electric meter keeps track of the amount of electricity that you are consuming. It does not tell you immediately or while you are using that you are using more or using less. It simply monitors it. So, monitoring is keeping an eye on the various process variables in your industry. A control action usually will not be taken for the monitoring purpose. So, next comes control of process and operations. So, the first one was only monitoring. The next is, which is most important application and refers to automatic control of processes, is control of process operations. So, here you not only monitor, you actually take corrective actions. So, it is the most important applications and refers to automatic control of the process. So, let us take an example to know more about it. So, this is a level control example. This is a level control example. We have shown a slightly different schematic in lecture 1. Imagine a liquid level is coming in to this tank and it goes here. You can control the level of the liquid in the tank either by manipulating the flow rate here or by here. Here we do not have any such valve. So, we will be controlling the level of the water in the tank using this. So, the first information that is required is what is the level at current time. So, you need a level indicator. So, the level indicator receives information about the level and it sends it to a level controller, and the level controller can in turn send signal to this control valve to open more or close more depending on the requirement, such that the level of the liquid in this tank is at the desired level. So, this is the control loop. Level indicator first receives information. Information goes to level controller. The level controller has set point information fed about the desired level. Comparing these two signals, level controller sends appropriate signal to the control valve to open more or to close more or do nothing depending on the requirement, such that the level in the tank remains at desired level. Another example is the control of bath temperature. So, we are talking about a water bath here. There is a steam coil passing through this water bath. By controlling or manipulating the steam flow rate, I can control the temperature of the water in the water bath. So, the purpose here is to change or manipulate the steam flow rate so that the temperature of the water bath remains at desired level. So, the first information that is required is the bath temperature at current time. So, once we have the bath temperature at current time, we can send this signal to a temperature controller. The temperature controller will have the set point fed to it. Temperature controller will compare the current bath temperature with the set point bath temperature, and if these two are not same, temperature controller understands a corrective action has to be taken. Accordingly, temperature controller will send a signal to this control valve to open more or close more, so that more steam is allowed to pass through or less steam is allowed to pass through, and the temperature of the controller, temperature of the water bath is maintained at desired level. So, we can have, at this stage we have some rough idea about the different control loops. So, what we see that in a control loop, different elements can be indicated as follows. First is a sensor or the measuring instrument that measures level in case of level controller, a sensor that measures temperature in a temperature control example, so on and so forth. Then that signal goes to a controller. The controller will be level controller for level measuring, level control example, it will be a temperature controller for temperature control example. The controller will have a set point fed to it. Sometimes the signal from the measuring instrument goes to something called comparator, and the comparator compares the measured signal with the set point signal and sends the error signal to the controller. Then depending on the error signal, which is the difference between the desired set point value and the current value of the process variable, controller will decide what is to be done, what control action has to be taken. Accordingly, it will send a signal to the control valve or actuator, which will implement the decision taken by the controller. So, the basic components that are involved in a control room is sensor, then comparator, controller, then actuator. So, sensor first senses the information about the system being controlled, controller takes the decision about what has to be done to the process so that control of variable is achieved, and actuator will implement that decision. So, this is true for whether we are talking about level control or whether we are talking about temperature control. This is in general is the principle of feedback control loop. Why feedback? Because the information about the medium which is being controlled is being fed for the purpose of control. So, if I now put this into a formal, what you call is as block diagram, it will look as shown in the slide. This is the process which I want to control. Let us say this is the water bath whose temperature I am trying to control. Let us say the temperature I want to maintain at 40 degrees Celsius. In a real process, there will be many disturbances which will try to take that temperature away from the set point. Because if there is no disturbance, you perhaps may not need a control action. Because there will be disturbances and the set point has to be maintained for all time, we need a controller in place. So, we first measure the information about the process using a sensor. So, for the water bath temperature control, we measure the temperature of the water bath by a temperature measuring instrument. This is called sensor. Then this signal will go to the comparator. This is the symbol of a comparator. The comparator has set point about the desired output. So, desired temperature 45 degrees Celsius. This arrowhead should be this side. This comparator finds the difference between this signal and this signal, and the error signal, which I can represent using epsilon, is fed to the controller. So, controller decides what is to be done, and the decision of the controller is implemented by the actuator, which in case of water bath temperature control is the control valve through which steam is flowing. So, in this class we are talking about this part of the process control loop. So, this is an important measurement applications. So, the first applications was monitoring or supervision of processes without any control action. Second is control of processes or operations, and when we talk about control of processes and operations, sensor finds a place here in this general feedback loop. So, this is a schematic of general feedback control loop. And finally, we have another important measurement applications, which is experimental engineering analysis. So, measuring instruments produce lot of data, and this type of applications is focused towards analyzing those data such that information characteristics about the process can be extracted from the data obtained by various instruments. For example, we can test the validity of prediction from theories. Let us say I am measuring a process variable and I have a theory which has a prediction for that process variable. So, I can measure a process variable with an objective to validate the prediction from theories. So, this is one application. We can build empirical models from data. This is another very important experimental engineering analysis. We have now several measuring instruments, very sophisticated measuring instruments, and they produce lot of good quality data. Now these data can be used to build predictive models. Please note that it may not always be possible to build a model based on first principles, that means using the principles of conservation of mass, energy and momentum. But the systems which are data rich and for the systems for which we do not have much understanding, it is possible to relate the output and the input from the data obtained. So, empirical models can be developed from such data. A good example will be building neural network models from the data obtained from various process industries. Characterization of materials and devices. Characterization of materials and devices. So, you can measure with an objective to characterize the material. So, you want to know what are the different properties of the materials. So, characterization is an important aspect of measurement. So, in summary, we have three different types of measurement applications. First is monitoring or supervision of processes and operations. Second is control of processes and operations, which is one of the most important applications of sensors. And third is engineering analysis, which is also extremely important these days, because particularly there are many complex systems which we do not understand properly, but with the advent of more and more sophisticated instruments, we can have lot of data about the process, and it is possible to build empirical models such as neural network models for predictions of such processes. Now, let us talk about direct measurement and indirect measurement. So, broadly we can classify the measurements into two categories: direct measurement and indirect measurement. As the name suggests, in direct measurement you measure the quantity directly. So, you determine the value of the quantity you are measuring directly. So, it does not involve any supplementary computations or steps. The measurement or the determination of the variable is direct. In case of indirect measurement, we measure a quantity which is related and then infer the value of the measurement from this measurement of related quantity. So, direct measurement, the quantity to be measured is determined directly. An example will be measure distance by scale, micrometer, vernier calipers, etc. Whereas indirect measurement, the quality to be measured is not measured directly, but other related parameter is measured and inference is drawn from there. Example, measure distance by optical method, where you use telescope to calculate distance. It is like you can use telescope to measure say the height of say a very high mountain. You do not have to take a tape and measure the height of a tall mountain. But what you can do is, you can use telescopic observations and make use of simple geometric principles to infer the value of the height of the mountain. So, this is an example of indirect measurement. Another example of direct measurement, the weight of a substance is always measured, can always be measured directly. Let us say you are measuring the bacteria count directly under microscope. So, you are simply counting the number of bacteria in a colony under microscope. So, that is an example of direct measurement. Indirect measurement, to measure power, we measure voltage and current and then compute power as product of voltage and current. Similarly, to measure resistance, we measure voltage and current and then compute resistance as voltage divided by current. So, the measurement of power and measurement of resistance is indirect measurement. Now, let us talk about various types of functions of an instrument. The primary job of an instrument is to measure a process variable. While doing so, it performs several functions such as transmitting, signaling, registering, indicating and recording. So, let us go through each of these. Transmitting functions. Instrument conveys the information concerning the measured quantity over some distance or to a remote point. So, an instrument when measures a process variable can indicate the value of the measured variable at the site of measurement, or it can convey this information about the measured quantity over some distance or to a remote point. Let us say you are measuring the temperature of the plates of a distillation column, but you are collecting the information at the control panel, say which may be several meters away from the site of distillation column. So, transmitting function is conveying the information concerning the measured quantity over some distance. A homely example is telephone. So, telephone transmits data. So, transmitters are used in process control loop. So, you have example of two temperature measuring instrument here. One is mercury in glass thermometer, another is thermocouple. Mercury in glass thermometer gives you the output directly at the site of measurement, because it indicates what it has measured by the level of the mercury against the calibrated scale. So, this does not transmit data, but in case of a thermocouple, thermocouple produces an EMF which can be very easily conveyed from one place to another, because it is an electrical signal. So, thermocouple is a transmitter. So, this is transmitting function. What thermocouple is performing is a transmitting function. Next, signaling. Here, instrument indicates the general value or range of values of its measured quantity. For example, a Grosser scale. Look at the Grosser scale. It tells you whether the object you are measuring is heavier or not compared to some standard. So, this gives you a signal about the general value or the range of the values of the measured quantity. Next is registering function. Here instrument indicates by numbers or some other symbols of discrete increments the value of the quantity being measured. So, here instrument indicates by discrete numbers most commonly, in some cases by some other symbols of discrete increments the value of the quantity being measured. A cash register is an example of this. Indicating type instrument, most of the instruments are indicating type of instruments. An indicating instrument indicates the instantaneous value of the variable being measured at that time. Such an instrument normally use a calibrated scale and a pointer. A homely example is the clock. Common laboratory instruments such as ammeter, voltmeter, wattmeter, laboratory pressure gauge are all indicating type instruments. So, here examples of a voltmeter which indicates about the voltage by movement of this pointer against this scale. Similarly, this is a common laboratory pressure gauge, again the measured pressure indicated by the movement of the pointer against this scale. Finally, recording functions. Here instrument makes a written record of the value of the measured quantity against some other variable, and most commonly it is against time. So, the recording function is that instrument will keep a written record of the process variable being measured against time. So, the most modern recorder is of course computer. You can make use of computer to keep record of the process variables that are being measured. There are many instruments available which can be interfaced directly with the computer. So, the computer can keep record of the variables that are being measured against time. On the left, this is an example of a circular chart and a circular chart recorder. So, look at here, this is a circular chart and this moves with a particular speed. So, this rotates. So, this rotates with a particular velocity. Now, you have pen attached here. Now, this pen, suppose this is a pressure measuring instrument, this is a pressure measuring recorder, So, this pen will continuously put marks about the pressure being measured with time. Now, since this is moving with time with a particular velocity and the plane always indicates the pressure that is being measured by a dot. At the end, if I take out this circular chart, I will have a curve something like this. This is not an example of circular chart, but this type of chart are also possible, but you can understand that similar mark you will get on the circular chart. So, I can say adjust the rotational speed of the circular chart, so that in 8 hours it completes one rotation. Normally in industry 8 hours is a shift. So, after 8 hours, when the next shift in charge comes, he can look at the circular chart and will get to know what happened to the pressure of that particular process for the last 8 hours. So, this way we can have a written record of the process variable that is being measured. So, this type of function is known as a recording function. So, we will stop here, and in the next lecture we will talk about functional elements of the instruments. Thank you.